So here in this problem, we need to determine the coordinate of the third vertex of an equilateral triangle. And if the other two vertices have the coordinates 3, 4 and -2, 3. Let's begin. Let's suppose we have an equilateral triangle ABC. Now the coordinates of B, that's 3, 4. Coordinates of C, let it be -2, 3. We need to obtain the coordinate of the third vertex. So let us assume that its coordinate is x, y. Now, how do we find out the coordinate of the third vertex? All we have to do is use the distance formula. First, what we'll do, we'll try to find out the length of each of the length of the side BC of the equilateral triangle. To obtain the length BC, we'll have to use the distance formula, which is specified here. Let's say we have 2 points, point A and point B, with their coordinate points given. Now, if we want to join A and B with the help of a straight line, then the distance AB is given by this particular formula. We'll take the square root. Underneath the square root for the first term, what we do is take the square of the difference of the x coordinate and then add it to the square of the difference of the y coordinate. So that means we'll have where square root of, now we'll take the difference of the x coordinate. So let's start with the x coordinate of B. From here, we're going to subtract the x coordinate of C. So minus of -2, that's going to make it +2. So we have 3 plus 2 whole square. Added to the difference of the y coordinate, so that will be the y coordinate of B, which is 4. From here, we're going to subtract the y coordinate of C. So that's 3. We have 4 minus 3 whole square. This will be equals to, we'll take the square root. We have 3 plus 2 whole squared, so that's 5 squared. Then we have 4 minus 3 whole squared, so that's 1 squared. 5 squared, that's 25. 25 plus 1, that's 26. So that means the length of BC, it's going to be square root of 26. Fine. Now, since it's an equilateral triangle, then length of each of the sides is also going to be square root of 26. Now what we'll do, we'll again use the distance formula to find out the length AB. So AB will be equals to, we'll take the square root. Now we have the difference of the x coordinates, so that's going to be x minus 3. Square it and add it to the difference of the y coordinates, so we have y minus 4 whole squared. So this will be square root of 26. Since AB has a length of square root of 26, this will be equals to square root of x minus 3 whole squared plus y minus 4 whole squared. Squaring both sides, we're going to get 26 equals to, so let's expand x minus 3 whole squared. The square root sign will go away. We have x squared minus 6x plus 9 plus y squared minus 8y plus 16. And then we can rearrange the terms to have x squared plus y squared minus 6x minus 8y. That will be equals to, so we'll transpose this 9 added to 16, which is 25, to the other side and combine with the 26 to get 1. So let this be equation number 1. So we have one set of equation. Now what we'll do, we'll try to figure out the length AC. So AC, again, we can use the distance formula. Let's take the help of the diagram. So we have x minus of -2, that's the difference of the x coordinate, x plus 2 whole squared, added to y minus 3 whole squared. So let's find this value. So we have square root of 26 equals to, underneath the square root, we expand the terms to get x squared plus y squared plus 4x minus 6y plus, so 2 squared is 4, 4 plus 9, so that's going to be 13. Now we can square both sides and rearrange the terms to get x squared plus y squared plus 4x minus 6y equals to 13. So let this be equation number 2. Now we have two set of equation 1 and equation 2. So what we'll do, we'll subtract equation number 2 from equation number 1. So let's do this, 1 minus 2. So this will give us, so x squared plus y squared minus 6x minus 8y equals to 1. That's equation number 1. And we have x squared plus y squared plus 4x minus 6y equals to 13. So that's equation number 2. So we do the subtraction. So here x squared and y squared will get cancelled out. We have negative 6x minus 4x, so that's negative 10x. Then we have negative 8y minus of negative 6y, that gives us negative 2y equals to 1 minus 13, so that's going to be negative 12. Now we're going to multiply, we're going to divide each terms with negative 2, so that gives us 5x plus y equals to positive 6. So this gives us a new equation, equation number 3. Now what we'll do, we'll isolate y from equation number 3 to get y equals to 6 minus 5x. So we will isolate y. So y will be equals to 6 minus 5x. So we get a new equation and we're going to name it equation number 3. Now what we'll do, we'll come back to equation number 2. So here equation number 2, we have x squared plus y squared plus 4x minus 6y equals to 13. What we'll do, we'll replace the value of y as obtained in equation number 3. That's going to help us find out the value of x. So we have x squared plus y squared. So y squared will be 6 minus 5x whole squared plus 4x minus 6 times y. The y is 6 minus 5x. Now this will be equals to 13. So we have x squared plus 36 minus 60x plus 25x squared plus 4x minus 36 plus 30x. That's equals to 13. So let's combine the terms. There's 25x squared and x squared will give us 26x squared. Then we have negative 60x plus 30x. So that's negative 30x, and negative 30x plus 40x, that will be negative 26x. Right. Now we combine all the constant terms. So we have 36 and negative 36 cancelling out. Now we are left with 13. So we'll transpose it to the left hand side. This will be equals to 0. Now we see that each of the terms has a coefficient which is a factor of 13. So we'll divide each terms with 13 to get 2x squared minus 2x minus 1 equals to 0. So we have a standard quadratic equation that's solved using the standard formula. So x will be equals to negative of negative 2 plus or minus, we'll take the square root. Underneath the square root, the discriminant will be negative 2 squared minus 4 times a times negative c divided by 2 times 2. So that gives us 2 plus or minus, underneath the square root we have 4 plus 8 divided by 4, which is equals to 2 plus or minus square root of 12 divided by 4, which is 2 plus or minus 2 times square root of 3 divided by 4. So we get x equals to 1 plus or minus square root of 3 over 2. Fine. So we have obtained the value of x. Now what we'll do, we'll go back to equation number 3. Y equals to 6 minus 5x to obtain the value of y. Y equals to 6 minus, now we will use equation number 3. 6 minus 5x. So we have two values of x here. So let's use when x is given by 1 plus square root of 3 over 2. So then y is going to be equals to 6 minus 5 times 1 plus square root of 3 divided by 2. So that's going to be equals to the common denominator 2. We have 12 minus 5 times square root of 3, which will be 7 minus 5 times square root of 3 over 2. So that means we have one coordinate. So we have obtained x comma y. So that's equivalent to 1 plus square root of 3 over 2. And then the corresponding y value is 7 minus square root of 3 over 2. Let's use the other value when our x value is 1 minus square root of 3 over 2. Then y will be equals to, we have 6 minus 5 times 1 minus square root of 3 over 2, which will be equals to, in the denominator we have 2, numerator we have 12 minus 5 plus 5 times square root of 3. So 12 minus 5, that's 7. So we have 7 plus 5 times square root of 3 divided by 2. So that's the corresponding y value. So x comma y now corresponds to, we have 1 minus square root of 3 over 2. That's the x value, and the y value is 7 plus 5 times square root of 3 over 2. So these are the two other vertices of the equilateral triangle. So it could be either this possibility. So it could be either 1 plus square root of 3 over 2 and 7 minus square root of 3 over 2, or it could be the other possibility, 1 minus square root of 3 over 2 and 7 plus 5 times square root of 3 whole divided by 2.